So my name is Sam Martindale. We're going to talk today about a project that we recently finished at our firm, where we built something a little bit different within NServiceBus. So what we built this time around was not the kind of prototypical examples of an order processor or credit card orders or one-off transactions. What we were actually building here was a file processing platform. This is a need we see quite a bit with a lot of our clients that come in. We do a lot of work in the healthcare, financial industries. Anybody who's in that industry? Yeah, so you guys probably know there's a lot of like EDI type problems, right? A lot of files come in from other partners, you got to deal with them, you got to do things, and it's not always a very simple problem. So a little bit of background about me, just because I'm probably the one person on this docket that everybody's looking at and saying, who? I'm Sam Martindale. I'm one of the co-founders of Architecting Innovation. We are a consulting firm based in Dallas, Texas, and San Francisco, California. We are an NServiceBus partner, so we do a lot of implementations on the platform. And you'll see our booth and some of our guys here in the back. You know, feel free to stop by and grab some stuff and talk to them. Let's jump kind of right into the problem. So what we're really looking at solving here is, how do we get, given a set of internal systems and a lot of disparate external data files, how do we get the data into our systems? On the surface, it's really an easy problem, and probably something that traditionally we can solve with just a simple ETL or SSIS or something like that, but we've got some extra parameters around this one that make it a little bit more difficult. So first of all, we need to automate pickup of lots of different file types to lots of different customers. This is not, you know, like 10 or 20 customers. This is on the order of thousands of customers, right? So a lot of different customers that we have to go pick up files from, move them in, all in different formats. So we get Excel, sometimes we get zipped up files that we have to know how to do different things with. We get XML, CSV, fixed width formats, and even within those subsets, they're not all the same, right? Customer might give it to us and it's totally different than the way the last guy had it, so we got to figure it out. Some other interesting kind of problems with this is we need to be able to perform record level logic and workflows. Maybe not down to the record level in each file, but certainly at the aggregate root. So if we take the data in a file together and we start building up what represents our domain objects, we need to be able to present or feed that into existing services, existing workflows throughout our enterprise to third-party web services, etc. We get a lot of different things coming in. We get new accounts, account payments, loan applications, very disparate across the file types. And what makes it even more complicated is some customers mix them and some don't. Some will give us a different file for each thing. Sometimes they're mixed up. We got to figure out what they are. But we need to get them through our systems, not just into the database. We have a lot of different integration points, and this doesn't begin to represent what we have to work with, but you know, just a couple of examples. We have to do things like address validation on new accounts that are coming in. We have to run credit checks on people. We have to process payments. We have to get things into our AP systems. We have to call other, both third-party logistics services is a good example of one that we have to call. We have to call a lot of internal processes and workflows as well. So we have a lot of integration points here. We need to be able to guarantee delivery. We can't take a file that's got, you know, 200 lines in it and lose 10 of them. They all have to make it, at least eventually, right? So we can't lose anything. And we have the problem of scalability, right? So I'm sure everybody's seen this silly picture before, but we have that problem of, you know, as we bring on more customers, we can't just tip over, right? We got to be able to scale out linearly and keep adding servers and be able to handle this. So why did we choose NServiceBus? Besides the fact that we're a partner and we wanted to speak at NSBCon, not really. But we did take a look at some other ones and we decided against it, right? So why? SSIS is an obvious one, right? Might be the one that we would take on for a problem like this traditionally. It's nice, it's simple, just code it, just get it done. Some of those other problems that we looked at, right? I mean, if we were to use this, it doesn't really make it very clean to extend the system as we go forward. Doesn't really make it easy to integrate with other systems. You know, this becomes, it's a much bigger problem than just ETL, right? We looked at BizTalk, Sterling, Axway, etc. What's the real problem with it? Despite being a Microsoft product and the whole developers bit, it's not really that developer. Anybody use BizTalk before? Yeah. So there's some development friction there, right? You got to know what it is. I've been in several places where they had an older version of BizTalk, and the only way to develop against it was to log into the one machine left in the enterprise that had Visual Studio 2005 on it. Redevelop your pipeline and all that stuff. Not very much fun. Additionally, it's a broker, right? It's not a bus. It just scales differently. It's got much different costs to scaling. Much more expensive. So we opted not to go this way. We chose NServiceBus because it's relatively inexpensive for licensing and relatively inexpensive to scale when compared to all these other solutions, right? And this is much easier to scale out. We get our message durability, and this is a great API for just regular .NET developers, which is great for us because as a consulting firm, we're in there doing this stuff for clients who need to be able to maintain it behind us. So we want to leave behind things that can be maintained behind us. We don't want to be stuck in a job maintaining this system for the next 15 years, right? So this is a great choice for us. So let's look at what we actually built. I'm going to walk through it, show some examples, and then we're going to talk about some of the things that we learned, and that's probably where we'll focus quite a bit of our time on, is what did we learn along the way after I just explain the system and what it is that we built, so that hopefully you guys can kind of learn from us and not repeat our mistakes. When I originally put the slide deck together, I pulled this out, but when I was practicing this at home, this is where my wife usually falls asleep. So had a little cute picture of her sleeping with her wine bottle, but she wasn't very happy with that being in there, so pulled that out. So what we built, right? We built this system that kind of starts with a scheduler. So like I said, we need to be able to schedule pickups files automatically, and they come in differently for every client, right? So we need a component that does that. Down into the file retrieval endpoint, which is going to be responsible for actually going out and getting the file, parsing the file, processing the file management, which we'll talk about here in a minute, some alerting, so we can notify users when things go wrong, be able to return parts of a file for reprocessing, things like that, and a web API endpoint that kind of keeps our dashboards and our monitoring up to date. Let's walk through those each one at a time. So the scheduler is straightforward. We need to be able to manage scheduled jobs for clients. I mean, this is a simple courts.net thing, right? But we just need to be able to keep track of when these files are scheduled to come in so we can actually go schedule a pickup. These files aren't getting uploaded to our site, and there's far too many of them to do it manually, right? So we need to go schedule a pickup for them. So this piece of software is simply responsible for knowing who's due to run when, what file types we need to expect, where to go get it, that kind of stuff. When that schedule endpoint picks up a job that needs to run, it's responsible for sending a command over to the file retrieval endpoint. So this piece of software is going to go pick up the file from whatever it is, FTP, SFTP, just a file share pickup, download from a website, web service, whatever. But it's going to do it based on client settings. Go ahead and pull it down for us, decrypt it if necessary, store it into our system so we can parse it. When it's done, it's going to send a command off to the parsing endpoint. And that parsing endpoint is responsible for knowing the different file types and how they parse. In reality, this is actually a collection of components. It's not just one, right? For simplicity's sake, kind of break it down to just one here. What this is going to do is going to take that file apart and shard it out into logical record sets. So anybody who's worked in EDI knows like one line in a given file isn't really necessarily an aggregate root or a record even, right? It could be multiple. You could have to take multiple together in order to make it kind of a transactional unit, right? So it's responsible for pulling apart those record sets and sharding them out across the next endpoint for processing, which is the processing endpoint. So this guy's responsible for getting into the database, and the most important thing here is this is really our extension point for getting data through the rest of the system. And as I said, in reality, this is actually kind of a set of endpoints, an array of endpoints, right? So there's like order-specific ones and payment-specific ones and things of this nature. So that as it takes them up, it can be able to go ahead and push them off into the rest of the system's raise events that we got a new order, we got a new this, we got a new account, whatever. So all those downstream systems can start to listen to those events and integrate and respond accordingly. File management endpoint. This is kind of sitting off on the side, and when I come back to the full slide and kind of show this all together again in a second, I'm going to explain how it's communicated with, but really what this is doing is a very simple task. It's just keeping track of the completion state of a given file. Is it complete? Is it not complete? How many lines errored? How many lines succeeded? Is there anything we need to do? Some clients don't want us to accept data if it doesn't fully go through, right? Some want their data back to fix, some don't care. Maybe able to handle it differently. Alerts. So in order to manage all that status stuff, we have to send alerts to somebody. Emails, dashboard updates, things of this nature. So we have an alerts endpoint that's kind of listening for different things to happen throughout the system. You know, even things that are a little bit less obvious, like there was a scheduled file pickup and there was nothing there. Right. So we need to send off something to like some external client or user. Hey man, we tried, but you didn't put anything out for us. And finally, the web API, right? So this is kind of listening to a lot of those alerts and pushing them back down through SignalR to the web browser that a lot of the internal folks are using to kind of monitor this system and keep track of what's going on. So as I put all this together again, what you'll notice is solid and dashed lines. So the solid lines are commands, so I was going through the workflow, and the dotted lines are events that are just notifying other components that, hey, something happened. A little bit more loosely coupled correlation there. Okay. So what did we learn along the way? We learned an awful lot. And quite frankly, some of these lessons were lessons learned from this project. Some of them were lessons learned from previous projects that I thought were relevant in this talk, because if we hadn't learned them already, we would have certainly learned them here. So the first thing we learned is, you know, really kind of the anti-pattern around monolithic endpoints. When we first kind of started this, there was a tendency on the team to want to put everything into the one service, to kind of organize our endpoints more like services rather than as endpoints, rather than as separate components. So in other words, we had the web API, which is obviously separate, the scheduler, which is kind of a separate service, the alert service, which is a separate service, and then kind of this file input-output that was really responsible for doing everything, right? Responsible for going to pick up the file, decrypt it, parse it, process it, keep status of it, all this stuff, right? So anybody have any idea what's wrong with that pattern? If we were listening to Jeffrey's the second talk this morning, you know, they did a lot of talk about separating all the logic out of sagas and some of the lessons that you can learn the hard way that way. It's kind of the same thing, right? We end up with this big kind of traffic jam of lots of different message types inside the same endpoint. How do we handle that, right? Certainly messages that are just trying to keep track of the status of a file don't have the same priority as actually processing the file. So we learned to kind of separate this out, right? And this is, again, I mention this because a lot of you know me, you know, been out to client site with quite a few of you and spent time with you. And I think it's the most common misuse that we see as an organization that's helping others to implement in NServiceBus is this concept that a service is really not an endpoint, right? A service can contain many endpoints to talk to each other. And I think a lot of people kind of adopt NServiceBus and start organizing their services in the same way that they might have if it was like a WCF, right? Where it's like one big executable that does everything. It's just not correct. And then, you know, the other bit here is scaling, right? I mean, so we can go to the extreme and have, you know, one handler per endpoint. Okay. That works in many cases is necessary, not always necessary. Certainly not necessary here. But we did at least want to think about how we grouped our handlers together so that when we did it, handlers that went in the same endpoint were roughly related and needed to scale the same way, had roughly the same SLAs, operated together, right? Sensible ways. What else did we learn? This was talked about a lot this morning. How do we scale a saga, right? And we kind of had two important lessons here, and I'm actually going to walk through an example. I can't show the real code because it's not owned by us, right? But we kind of put together like a loose demo to kind of show the things that you can do wrong. You know, when you're putting your saga together, it's very common, I think, first time off the bat, to put all your logic and all your orchestration inside the same class. And this was talked about a lot this morning, so I won't beat it to death too much, but you know, there's a big problem with scaling that saga, right? So if we think about the saga basically equates back to one database row that's keeping track of the state of that saga. So every time you have to read the saga, you're reading that database row. Every time you have to update the status, you're writing that database row, which means if there's contention or conflicts, and there's multiple messages that could come into the same saga at roughly the same time, you can end up in kind of a world of hurt, right? It's not going to scale past how fast that can read and write. And if you have a really long-running handlers inside the saga, that's not very fast. You're going to get a lot of messages that fail on concurrency exceptions, roll back, have to try again. And now suddenly you've got this bottleneck that is slowing your entire process down. A resolution, keep it simple. You take everything out that's not orchestration, and I think it was said this morning, and I just reiterate it, Saga shouldn't be the first answer. Right? If you can handle it with normal endpoints and just chaining events along or chaining commands along, that's really the way it ought to be. If you need to keep state across all of them, fine. Then we can put a Saga in, but we've kind of learned in most cases that the sagas should really kind of sit on the side and listen quietly, not be directly involved with the work, right? So let's take a look at that. What's that actually look like in practice? So what I have here is a simple solution with not everything implemented out, but some of the endpoints that we need put together. And I've got two different implementations of this particular saga in here that we'll look at. So if I go look at that file management saga, I've got two different endpoints, so I've gone ahead and split them out. And we'll look at the bad one first. So how does the bad one do it? Well, what this saga is doing, and just to kind of give an overview, I'll go up to the top to kind of tell you what it's doing. It's started by an event that comes in that says an incoming file got parsed. And on that event, what we have is the total number of records that we need to expect in order to call that file complete, along with a file ID that we can correlate it with, right? So we have a total line count. And again, this saga's job is to keep track of what the overall status of the file is. When's it done? How many errors did we get? How many did we actually get processed completely? What do we need to do next, right? So the next event that it's listening to is actually coming from a different component. It's coming from a processor component. And it's telling it that a record set was processed. And it's telling it inside there how many of the lines inside the original source file were incorrect and how many were correct, so we can kind of keep track of the running totals. So if you think about that, what that means is this saga should be complete when the total number of expected lines matches the total number of errors plus the total number of success, right? Which you can see down here. Pretty simple implementation. Okay. So that's all fine. That's all pretty straightforward. Does anybody see what the problem is with this saga if it's listening to the parsed event and all these processed record events coming in at the same time? Potentially if we have like a file that had 100 record sets inside it that came across. So we start getting a lot of contention when all the record sets coming in, right? So all these, like, I processed a record set events coming in. This gets really hard to manage. You're going to get a lot of rollbacks off of something that should be as simple as just tell me when it's done. And now this is kind of rolling back. So what do we need to do differently? Besides listen to the when to start and all these kind of events coming in telling me a quick status update, what should we do differently? Well, it's frankly pretty straightforward. Inside the new endpoint, we're going to go ahead and have a new saga that we put together. This one started the same way. It's going to start by listening to the I parsed an incoming file event. This time, though, it's not handling the second event. What it's going to do instead is just have a timeout on itself. So it has some timeout registered for I should check to see if the file is done. Let's look at what this actually looks like in practice. So when it gets that first started message, it does some stuff. And by the way, I'm doing warns here, not because they're warns, because yellow shows up better on the screen when you're presenting. But what what it's doing is going ahead and setting some Saga data up. All right, file ID. I'm going to set a start time just so we can see it kind of ticked out on the output when we compare the two. I'm going to set the total parsed equal to the total line count that came in, and then I'm going to call something called check status. So let's go see what check status does. Check status is just going to do a get counts, which I'll show you what that does in a second. Presumably all it's doing is it's reaching out somewhere to read off of something else how many are processed or how many are done instead of waiting for every event to come in. If the number that have been processed or errored is greater than or equal to the number that we expected, we're done. Otherwise, what are we going to do? We're just going to log that we're still going, and we're going to go ahead and request a timeout to check to see if the file's done. Let's go see what that timeout handler does. So when I call this timeout here, it's just a loop. Incredibly simple implementation, right? And yes, in production, this has more stuff to it, but it's not much more. So what we've done is we've taken a Saga that was responding to potentially hundreds of events coming in, and we've taken it to listening to one event, and then in a very controlled manner, looping in on itself. So there's no risk for like contention and rollbacks and all these other things. Now what I've got in this solution is a couple of different projects put together. I have our parser endpoint, which really isn't doing anything in this particular solution. It's kind of irrelevant to the talk to build out a whole file parser. But what it does do is just kind of fakes it. So when I start that up and hit enter on it, it's just going to publish that event for me and just kind of kick off the whole process. And it's going to send some commands to the processor to fake process some records. If I open up the processor, so that was the parser. If I open up the processor, when it gets the process a record set command, it's going to do a little sleep to simulate that it's doing some work. It's going to do a math random for me, so I can fake an error versus success count. I'm going to stick those back onto the all done with this record set event and publish it. So we're just faking it. I'll come back and show you the rest of that in just a second. And then our Saga is the one that we just saw. So let's look at this while running the first version of this Saga, as well as running the new one together. And let's see how this works. So just kind of get those arranged there. So we've got the parser up top, processor the next one down, the old implementation of the Saga below that, and finally the new implementation of the Saga. So let's take a look. We'll just kind of fire off the parser, which again is going to fake start a process for me, the parsing file or the parsing process, send some commands into the processor, which if you can read that, you can see it faked a bunch of record sets actually being processed and published out some messages. And we've got an old implementation of the Saga, the one that was listening to all the events, and then the one that's operating on timeouts down below. If you take a look, the one that's doing the timeouts is already done. Can you guys read that way back there? Down there at the bottom? So Saga completed in roughly 4 seconds. The second one, this is still running. It's actually like dumping things out to SLR at the moment, right? So there we go. Now it's finally done. 41.51 seconds. It's a big difference, right, in how these two get implemented. And if I go take a look at what all these errors were that it was dumping out all along the way, they're all concurrency exceptions. Because you get like 2 events coming in at roughly the same time, one of them is rolling back, and then trying again, trying again. So what we learned was just how to control this stuff, right? And how to implement this in a way that made a little bit more sense. Yeah. So all that's doing, in this implementation, it's a very simple one. So I'm glad you asked that, because that's actually what I wanted to go into next, is what that's actually doing here, for the sake of demos, right? In production, the way we write this is much different, but in a demo, we want it to be as clear as possible. We don't want to hide things, 2 or 3 layers down. So what is this doing? Simply inserting it into a table, because there's not going to be any contention for an insert, right? So when you're updating, you got to worry about it. So all I'm doing here is just inserting into a table against that file ID, which was that GUID that I got when it came in. How many errored, how many succeeded. And then that second saga that's doing the new implementation, is just selecting it. No. 1 insert per record set. So there's going to be a bunch of them. It's grouping them all together, right? So if I look at this, it's doing a sum of error count plus success count, so it's taking a bunch of records, collapsing them down. So this is essentially what I'm trying to get to, right, is we're moving away from, in the saga, you've got 1 record that's being held by the saga, right, that's getting updated. We've moved out of updates and essentially into, we're just going to insert this into different places and just sum it all together, right? Yeah. Mm-hmm. Yeah, so that's a really good question. So in practice, what's missing here, right? And so this is a demo that's put together for this. But in practice, what you actually have is you have a second timeout that says, like, okay, if this breaches some SLA, like 30 minutes or an hour or 5 minutes or whatever, then what it needs to do is raise an event to say, I completely failed. That's going to go off to the alerting queue, get sent back to a user, get handled in some different way. Maybe the original file is delivered back to them so that they can look at it again. Gets handled, right? But we don't just let the saga run forever. We want to kill it at some point. Does that answer your question? No, it's just for demo, right? So what I would do in that case, right, is just have some second timeout here that just says, I failed totally. Yep. Yeah. And at some point, all you do is you just mark the whole saga as complete, and you raise some event that says I failed, which some other endpoint is now listening to that's going to say, okay, collect up the file, send off an alert, send an email, do some things. Okay. So this is kind of what we're talking about here as we look at like all these different events coming in. I completed 3, I completed 3, I completed 90, I completed 32, 13, 2. This first implementation, what we saw was the saga was just too busy to keep up. It just couldn't do it. There are too many messages coming in all at once. When we switched over to the second implementation, which is we're just going to schedule ourselves to just check, just write all these to the database and just check it. That tells us a lot better. We get to know what's going on, and we don't have all the contention problems. Other problems we ran into, and this is one that we run into everywhere we go, is deployment challenges. Yeah. Mm-hmm. Yeah. That's great news. Is that in 5? Cool. All right. Thank you. So other problems that we ran into going through this, deployment challenges are always a pain. And to go back to the kind of monolithic service design that I think a lot of people have a hard time with, you know, adopting the fact that a service and an endpoint are not the same thing, and now your service is going to be many endpoints and components that get strung together throughout the environment. A lot of folks struggle with this, particularly because they come to the deployment side. And this is harder to do than deploying one service, right? So how do we solve this? How do we get people over this? Because we kind of battle it, especially as a consulting firm, getting people to adopt these technologies over and over and over again, right? It's battle everywhere we go. So these are things that we script out as best we can, and I'd like to try to share some of that stuff with you guys. So what we looked at here was really scripting out two things. I'm going to jump down to my folder here and actually open these up. We have two PowerShell scripts that I'll open up one at a time, but one is called package build and the other one is called release build. We could do these in a lot of things. Octopus would be a lot cooler and probably a lot more relevant to some of you. As consultants that go from place to place, we never know what's going to be in place. We need something that's a little bit more common, lowest common denominator. So we opt to use PowerShell. And when we take a look at what some of these are doing, in this package build, it's pretty straightforward. It's taking in my solution and doing an MS build on it, and doing essentially configuration transforms, right? So if you're used to the whole like app.dev.config stuff, that's all we're really doing. Take all those, transform them against me for my current environment, and tell me what the results are. Actually merge them in. So if I go take a look at something like alerts, you know, this is pretty straightforward. I think most of you have probably seen it. You know, you end up with like a regular app config and then an app.whatever environment I'm in .config, where it's some transformation that I get to remove things or override attributes or do different things. So when we go actually execute this, what we'll see is, you know, these just get replaced. And finally, what it's taking is copying all of those deployable units up to a package folder so we can deploy them here next. It's not getting everything. It's getting everything according to a pattern. So whatever has the names that we commonly see used for endpoints, we like .endpoint, but it's not everybody we see. So we've got some other includes there as well. So let's take a look, if we go ahead and build this one, what it's going to do. Let's say build, package build. I'm going to give it a couple of parameters. So I'm going to tell it the environment that I want to build for and the build configuration that I want it to use in Visual Studio. And it's going to give me a bunch of stuff. I made this font really big so you can read it from the back, but it almost looks too big. So that's it. It's done. So all that's done is really just package up this build for me. So if I go take a look inside my package folder, you notice it's only copied over the deployable units according to what was named .endpoint or .handlers or .service or whatever. So what I've got is I've got all these in there, and if I want to go actually take a look at one of these config files, it's been transformed according to whatever the transform said. So that's fine. That one's not really that interesting. It's kind of just setting us up. Let's take a look at release build and what this is doing. This is a bit more interesting. So what we've tried to do is take all of those units that are inside the package folder, and now where are we going to deploy them? So this is looping through essentially an XML file. And that XML file is pretty straightforward. Let's show one. And that XML file is going to be our instructions for how to deploy. Set kind of easy to read, not really. So what we've got here is we've got a XML list of what servers we want to be able to deploy to, each server name, the path to deploy to, the service account that we want to run under, a password back there that you can take my word for, the service name that we're going to deploy, endpoint name, and the type, independent distributor worker. What these scripts are going to do is it's going to loop through all of these, and please note, there can be multiple of these, right? So we can deploy across a bunch of machines, different services to each one. That's kind of what we want to be able to do, right? So what this is going to do is it's going to go through each one of those and actually copy them over to a staging path on the target server. If there's anything already in the services path, which is what's in production, let's back it up, let's date it out. Let's copy our stage over, let's do an uninstall, let's clean everything up, let's reinstall, and let's start the services, right? So let's go ahead and run that one and take a look and see what it does. Same parameters. I'm going to tell it what environment to deploy to and under what configuration. And it just starts going through. It's actually launching uninstallers, launching installers, doing different things. So we're making use of a lot of what NServiceBus is, because it gives us so much, right? The install and uninstall and all the parameters you can pass it to get it in distributor or worker, all these different configurations, very useful. Just leverage it. What it's doing in the background is a lot of the PowerShell heavy lifting, and then for our worker nodes in particular, transforming those config files again so that it knows where the master node config is, who its distributor is, essentially. Because I don't know if anybody's noticed that or not, but if you run locally with like a master node already configured in there, it turns off a lot of features that you need when you're developing locally. So that's it. It's deployed. The service is started. And if we go actually take a look at where it deployed to, what we'll see is, kind of that folder structure that it set up for us of having that stage, the services where things are actually deployed, and the backups where it's keeping dated versions of everything else, right? So a lot of our pain was rooted in the fact that it was too much to deploy, right? Particularly when you're building out projects that, this project in reality, here it's got, 7 endpoints? In reality, it's got like 20, right? So there's like a lot of different processors and different things going on. So that's way too much to manage yourself. And so we wanted to build out something that we could keep reusing from project to project. These scripts are available if anybody wants to use them. You're certainly welcome to them. They're written to be, good for anybody. So just, come get them. I know Udi's got plans to build a lot of this stuff in on the particular platform. I'm sure that'll be a lot more mature, so we look forward to that as well. And the last real big issue that we wanted to talk about is this problem of deploying into new environments. It's difficult. There's always misconfiguration. There's always a network issue. There's always security issues. Always something gets you every time you go into a new environment. So one of the things that we learned along the way is to invest heavily into custom checks and building out as many as we could to check these things, right? Because we'd rather find out on our terms than just one of the 14 different worker nodes didn't start up and you find out the hard way later, right? So, we have a lot of different custom checks written. Some I can share, some I can't share because they're, owned by someone else now, a client. But, I'm happy to share anything that I can. If you want to grab me afterward and ask. Everything that we try to do is around environmental stuff, right? So checking to make sure DTC is turned on. Wrap yourself up in a scope and hit a couple of databases and see if it's enabled. RavenDB, make sure that 8080 port or whatever port you're running on is open. Been a lot of environments where it's not open, particularly in finance and healthcare where everything's like locked down to the nth degree to start with. Checking FTP sites. So in this particular project, one of the first things that we did was check out our internal FTP, because that's where about 80% of the clients dropped their files for us. The other 20% kind of dropped them elsewhere. So all right, let's make sure at least the big one's available and up and running. Password's good. Something we learned early on, right, was I think we were in production for maybe like 2 months, and somebody in operations decided to change the password. Okay, thanks, right? So this is one of those that we run now as a periodic check. You kind of run it every so often and make sure we're still good. And make sure the data bus is reachable, right? If we have some like SAN for the data bus, we want to make sure that we can reach that. So let's go take a look at some of those. I think they're pretty straightforward, and I didn't want to go too deep into these, so they're not too complex, but just if nobody's ever seen a custom check, I wanted you to at least be able to see what it was. So this is really nice, introduction with the Service Pulse, Service Insight stuff. Is we got the notion of being able to do custom checks. We add this extra NuGet out to the, I always forget the name of the assembly, the Service Control Custom Checks plugin. And we get these extra classes that we can inherit from now of custom check or periodic check. Custom check runs once at startup. We're able to actually do some work and report a pass or fail. Periodic check you can set up to run it at intervals, like the FTP one. But essentially what we're doing here is we're saying, okay, let's go check the database connection. And ours is actually an abstract class because we reuse these, right? So when we implement it, we just inherit from this and pass in the connection string that we want to check connectivity to. And so what this is doing is it's just newing up some SQL connection test. Essentially all that's doing is like a single select, right? Select count 1 out of something, just see if we can get to it. And you either report a pass or you report a fail. So all this gets fed back to the particular platform that gives us that nice Service Pulse tool where we can see the custom checks. I think Udi showed it in his talk this morning. You get that nice dashboard where you can see all your failures for custom checks all at once, be able to see what's going wrong. So we leverage these quite a bit in our development as well. Any questions? So I'm wrapping up. Looks like right on time. I've got just a few minutes. What was our impact? A lot faster processing times. We're just north of about 10,000 records per second parsed and processed per worker. That's not a record set. That's a record from the original file. So these are grouped and sharded together. That's not how many messages we're processing per worker. It's how many records are making it through. Now, that's, to kind of put this in perspective, it's about 10x of what they were doing before we came in with their original processes, but that's not really the real story here, right? Really the success story is in the fact that they're not waiting for nightly jobs to run to call address validation, which are then chained to nightly jobs to run for credit approval, which are chained to nightly jobs for something else. The nightmare before we came into this was, you'd get a nightly job that would fail, and that starts kind of chaining down, right? You get this problem that's like a week long where nothing happened. So what we're able to do now is because we're chaining all these events together through disparate endpoints with just events, if things fail, it's not the whole file that failed, it's not the whole job that failed, it's one or two that can be managed through the platform. A lot happier users, a lot happier developers. When we came in and replaced this, it was actually written across, I forget exactly how many disparate applications were doing all this work before we consolidated down to one, but it was well over 100. And they were written in languages I've never even heard of. Anybody ever heard of E=C? Yeah, it's crazy, archaic languages. And there was actually a language called 4GL, which I never knew existed. Not a category of languages, a language called 4GL. And a lot happier executives, right? Because now what they've got is the ability to kind of scale out. So they'd spent 25 years every time they brought on a new client of significant size, separating the entire environment, like new database, new everything, because they didn't know how to separate their applications or scale this thing. So Now, for the first time in their 25-year history, they're starting to move back down to like getting the environment back in like a manageable shape, because it hasn't been for a long time, right? So clearly a big impact for this company. I think got 3 minutes left and right on time, so it's a good time for questions if you have any. Yeah. I can't hear you, I'm sorry.
Are you deploying in a hot environment, or do you have downtime where the queues are empty?
Oh, do we have downtime where the queues are empty is the question. Yeah.
If you deploy in a hot environment, it seems like you'd have a problem with when you tear the services down with some of your PowerShell scripts there, that if they were hot,
Yep.
some of those queues are going to get, some of those errors are going to occur, and the messages are going to return to queue, your timeouts are going to occur, and your counts are going to go off.
Could. The implementation in reality around the timeouts is that they're not actually that simple. The timeout's actually a little bit more complex than that to take that into account. But the answer is yes, we are deploying into hot environments. We are a little bit lucky in that we have known downtimes that we can deploy out to. So we have times where we know there's like empty windows where nothing's scheduled. So keep in mind with this system, the one thing that we kind of have in control, under our control, is that we're running the scheduler, which means we know when everything's set to run and when it's not, and we know when there's going to be holes in the schedule. So typically late night Pacific time on the weekends, we have a couple hour hole where we can deploy out. But that's a really good question, right? Because if we were deploying into a hot environment, in theory, everything would be fine. It'd sit in the distributor queue until we come back up, but the problem would come into timeouts. Particularly our timeouts to start killing sagas and doing some different things, right? So we have a little bit more complex implementation around those timeouts, where we're actually like counting time between messages and seeing what's going on, trying to determine if a service is down. But yeah, good question. I thought I saw another hand over here. Yeah.
I was going to ask you, you guys leverage PowerShell scripts pretty extensively. Do you guys ever have scenarios, or is it a common scenario where you actually wind up overriding the unicast bus config so you kind of build once and deploy to any environment? So in a scenario where right now one of the issues we run into is that all of the configuration is in the web config or in the .config file, but we try to keep our code in one deployable, and then as we move from dev to QA to load testing to production, we don't want to change the configuration values, so we try to keep those configuration values out into another file or something that's environment specific, because we don't always control the passwords. There are different groups and different responsibility chains. So I guess the question is, one of the things we were looking at was possibly just pulling things from a configuration service or pulling them from a separate file that loads and injecting them via the unicast bus config. Have you ever used that scenario, or is it one that's feasible?
Being able to pull out properties out of a configuration file and inject them into the unicast bus config. Do you mean in the endpoint config, like you're changing static code, or you're changing values in the message endpoint mappings?
So the database connection string will be different from one database environment to another. Currently, or endpoint config is a good example. We run a distributor worker scenario. So the distributor name that you have to put into the unicast bus config, the at this server name, that's going to change from dev to QA to production. But then we have to go in and kind of scrub our config files in each environment.
Let me just make sure that I'm understanding you correctly, if you don't mind bearing with me for a minute. So are you saying that you're changing something in here? No, you're saying that you're changing...
The idea that we're toying with is possibly programmatically injecting the configuration instead of reading it out of the .config file. Because in the .config file right now, because it's that root level that's within the package that we're deploying, is very environment specific. So as we go from one environment to another, we have to change this file that we're looking at right now and change server names, change...
Okay, I understand your question now. I think I was making more of it than it was, but yeah. So the question is, do we need to be able to change the server names and the different things in the config file? Yeah, absolutely. So that's what that package does, and it's looking at that delta config file, which is there to override anything that we need to override, right? So if we need to remove nodes or set attributes on a node, and I've actually got examples. If you want to come grab me afterward, I've got specific examples that can show you what needs to happen to change it from independent, which is how you run locally, into distributor worker. And I'd be happy to give you those delta configs, because it's all figured out, right? Essentially what it means is you're changing the server names on the distributor nodes and you're inserting a master node config, right? Anything else? All right, guys. Thank you.